Volume of a solid of revolution. So what is a solid of a revolution? F of x is part of a parabola. Let it revolve around the x-axis. And what will you get? You get a solid. By rotating this curve about a given axis, in this case the x-axis. So now, how do we find the volume of this? In order to find the volume of this, we need the area of the cross-section of this solid. First of all, this is a circle. Second, the circle's area is pi r squared. In this case, r equals f of x. Therefore, pi times f of x squared is the area of the cross-section. So, the solid is an infinite amount of cross-sections that are added together, and therefore we get the equation volume equals the integral from a to b pi times f of x squared dx, which is equal to pi times the integral from a to b of f of x squared dx, or also known as pi times the integral from a to b big R squared dx. So this is our formula. Volume equals pi times the integral from a to b big R squared dx. So when to use this formula? When a given function is rotated about an x-axis. So just look at the formula. Alright. So example number 1. Find the volume of a solid obtained by rotating the region bounded by y equals x squared minus 4x plus 5, x equals 1, x equals 4, and the x-axis about the x-axis. So to the left, we have the graph of the bounded region, and to the right, we have the graph of the object. So in this case, the cross-section is a circle, and the solid comes from all the circles added up together. And we will be using the formula from the last slide, volume equals pi times the integral from a to b big R squared dx, where big R is the radius. So we'll use the equation y equals x squared minus 4x plus 5 for big R. And we'll be using this formula again. So plug in the equation for big R squared. So now we have pi times the integral from 1 to 4, x squared minus 4x plus 5 squared dx. So we can multiply this out to get this equation. And then we'll find the antiderivative of this. So now it will be pi times 1/5 x to the 5th minus 2x to the 4th plus 26 over 3 x cubed minus 20x squared plus 25x. So then we plug in 1 and 4 to we plug in 4 into the x's, then subtract that from after plugging in 1 into the equation, and you end up with 78 pi over 5. So what if you have two functions, and the question asks you to rotate the bounded area to rotate around an axis? So we use the formula volume equals pi times the integral from a to b big R squared minus little r squared dx. When to use this formula? When asking to rotate the bounded area by two equations around a given axis. So example number 2. Find the volume of the solid obtained by rotating the portion of the region bounded by y equals the cube root of x and y equals x over 4. That lies in the first quadrant about the y-axis. So to the left we have the graph of the bounded region, and to the right we have the graph of the object. So in this case we have to make x equal f of y. So we will change all of our equations from y equals cube root of x to x equals y cubed, and y equals x over 4 to x equals 4y. In this case, the inner radius, little r, is equal to y cubed. The outer radius, big R, is equal to 4y. So little r, big R. And the cross-sectional area is a of y is equal to pi times f of y, 4y squared minus y cubed squared, which is equal to pi times 16y squared minus y to the 6th. The first cross-section occurs at y equals 0, and the last cross-section occurs at y equals 2. So we will use the formula volume equals integral from c to d of a of y dy, which is equal to pi times the integral from 0 to 2, 16y squared minus y to the 6th dy, which is therefore equal to pi times 16 over 3 y cubed minus 1 over 7 y to the 7th power. So then we plug in 2 and 0, and we end up with 512 pi over 21. The end.